This video is going to show how to configure constraints to improve AI-generated results in OrCAD X. When incorporating AI, it's important to provide clear and concise guidelines to generate a board that is functional and manufacturable. For best results, designers should configure constraints and certain settings within the PCB design software to prevent errors and violations during AI-generated placement or routing. Start by opening the provided design in OrCAD X PCB Designer. First, let's define rooms for this board. Rooms can be used to keep critical circuitry together and shorten connections. For this design, rooms have already been defined in the schematic. To define room areas on the board, select Shape Rectangular from the menu. In the Options panel, set the active class to Board Geometry and the active subclass to both rooms. We can make our room placement a bit more accurate by snapping the shape to the already drawn outline. Right-click the upper left corner of the board package heap and select Snap Pick to Segment Vertex. One corner of the shape is attached to the vertex and the other is attached to your cursor. Move the mouse to the center of the board to create a room area in the upper left corner. Click to place the rectangle. The first room space has been defined. This design is a total of 3 rooms. To define another room, let's use vertices again. Right-click the bottom left corner and select Snap Pick to Segment Vertex. From here, we can right-click the bottom right corner of the first room and select Snap Pick to Segment Vertex to create the new room. Let's draw the last room. Right-click the upper right corner of the first room and select Snap Pick to Segment Vertex. Right-click the bottom right corner of the board and select Snap Pick to Segment Vertex. When finished, right-click and select Done. The room geometry has been defined. Next, we need to annotate each room. To do this, select Add Text from the menu. In the Options panel, set the active class to Board Geometry and the active subclass to both rooms. Set the text block to 6 to ensure the text is large enough to read. Select a room to define it as the active room for the text. Click anywhere inside the room to place the text. For this example, we'll start by defining the HDMI room. Once you've entered the room name, click outside the room to deselect the text. Repeat this process to define the RGB and power rooms. When finished, right-click and select Done. Now let's define constraints in the Constraint Manager. We'll start by defining differential pairs. To open the Constraint Manager, select Setup Constraints from the menu. In the Constraint Manager window, select the electrical domain from the worksheet selector. Expand and select the Net Routing Differential Pair worksheet. This worksheet lists all nets in the design and their assigned electrical constraints. Let's designate the 4 HDMI data lines as differential pairs. Scroll to the bottom of the net list to view the nets. Assigning these nets as differential pairs will ensure they are routed together and that all differential pair constraints apply. Right-click one of the nets and select Create Differential Pair. The Create Differential Pair window opens with the selected net listed. Here you can select nets to create differential pairs manually. To create multiple differential pairs at once, select Auto Setup. The Differential Pair Automatic Setup window opens. Here you can define multiple differential pairs by net suffix. In this design, all positive nets end with P and all negative nets end with N. Enter P for the positive filter and N for the negative filter. Click outside the text fields to generate the list. The table is populated with differential pairs TXC, TX2, TX1, and TX0, which are the 4 HDMI data lines. Click Create to create the differential pairs. A log file opens, showing the pairs and their associated nets. Close the log file. Click Close in both differential pair windows to return to the Constraint Manager. Now let's define physical constraints for this design. XAI will follow layer sets and assignments, minimum line width, and minimum line spacing and primary gap rules. Select the physical domain from the worksheet selector. From there, select the Physical Constraints All Layers worksheet. A table of physical constraint sets is shown. These constraint sets can be assigned to multiple nets in the design. To create a new constraint set, right-click the default set and select Create Physical C-Set. Enter a name for the constraint set and click OK. The constraint set is added to a new row in the table. For this example, we will set the minimum line width, minimum net width, and maximum neck length to create a power constraint set. Let's create a constraint set for differential pairs. Right-click the default set again and select Create Physical C-Set. Enter a name for the set and click OK. For this constraint set, we will define the minimum line spacing and primary gap to ensure the differential pair is routed correctly. Now let's assign these constraint sets to the appropriate nets in the design. Select the Net All Layers worksheet from the physical domain. A new table is shown with a list of nets and their assigned physical constraints. Constraints can be assigned to multiple nets at once. To do this, click and drag the cells under Referenced Physical C-Set for the desired nets and select the desired constraint set from the resulting drop-down. We can do this to assign the defined constraint sets to differential pairs and power nets. All power net names in this design start with a plus or minus sign to ensure they line up in the constraint manager to make this easy. Now let's define spacing rules. For copper plane generation, plane spacing must be defined to prevent shorting errors. Select the spacing domain from the worksheet selector in the Spacing Constraint Set All Layers worksheet. A table of spacing constraints opens in the Constraint Manager window. Scroll to the Define Shape-to-Shape spacing in the default constraint set and select the cell to edit it. Enter 0.254 and click outside the cell. This will ensure a gap of 0.254 mm between all copper planes. Next, let's define DC net voltages to flag the power and ground nets as DC. Select the Properties domain from the worksheet selector and select the Net General Properties worksheet. All nets in the design are listed with their properties such as voltage, weight, and routing priority. Enter the defined DC voltage for each net. Scroll down to Net 0, the ground net, and enter 0 for the voltage. The nets will now be shown in the power and ground plane settings in XAI. Close the Constraint Manager. To save the board, select File, Save from the menu and click Yes if prompted to overwrite. With constraints and rooms defined, we are ready to import the board into XAI. Select Tools, XAI from the menu. Select Login and enter your Cadence username and password. A list of available workspaces is shown. Select Create New Workspace at the top of the panel to create a new workspace. Enter a name for the workspace and click the checkmark button to create it. The main window for the workspace opens. Click Upload Board to upload the currently loaded board to the XAI server. With the board loaded, let's look at the rooms and voltage nets defined earlier. Select Room Placement to open the Room Placement table. The table shows all rooms defined in the PCB. The HDMI, RGB, and power rooms are listed as we define them. From here, you can choose whether components in these rooms should be placed within the rooms defined on the board. Click Save or Cancel to return to the main window. To view the power and ground net voltage assignments, select Power and Ground Setup. The Power and Ground Setup table opens. The top row shows the defined power and ground nets with their number of connections and assigned voltages below. With constraints configured, the board is ready to be built in XAI. Quickly and easily configure constraints and design settings including rooms, physical rules, spacing rules, voltages, and more to ensure AI will return results that meet your design and functionality criteria with XAI and OrCAD X. For more tutorials, visit us at resources.ema-eva.com and don't forget to like and subscribe to our YouTube channel.